distance from the centroid. Okay. Then we have the next one, right? We can also have moment about moment about y, which is equal to Vz multiplied by L. Okay, so this is the moment about the y-axis. And this will contribute to normal stresses. In the x direction, you have my over Iyy multiplied by z. Okay. So just to quickly recap, so what do we have? Okay. So in a structure under combined loading, right, you have axial forces, you have shearing forces in the y and the z direction, you have moment in the y and z direction, and finally one more, right? If we have a twist, right? So this is our talk about the z-axis. Okay. So given a twist, right, it's a rotation. I'll write on this side of the page. So we have Tx, which is the torque applied, or the torque about the x-axis. So for this case, given the torque, we have shear stress is equal to Tx multiplied by R divided by J. Okay, where R is the radius of the shaft and J is the polar second moment of area. Okay. So we realize that we have to again, okay, I've just shown you what are the applied loadings. Okay. From the applied loading, so we have shear force, axial force, shear force, bending moment, and torque. And I show you the respective moment. Okay, given axial load, what is the formula to use, right? So if it's axial load, these are the formulas that you will use. Okay, so the respective formulas are all here, right? If shear in the y direct, shear force in the y direction, shear force in the z direction, right? And then we have moment, moment about the z-axis, and then moment about the y-axis, and then finally we have torque. Okay. So in order to calculate all this, you have to be able to identify what are your shear force, what are your bending moments, and what are your axial load. Okay, without these values, you're done. Okay, you cannot identify any, you cannot calculate any stresses at all. So now I'm going to combine all the equations now. Okay, I'm going to, so we happen to have three normal stress, right? Stress x equal px over a, stress x my over I z multiplied by y, stress x equal my over I y multiplied by z. Then we have shearing stress. Okay, so at the end of the day, we are going to combine. Okay, we are going to combine stress x is equal to px over a, right? Plus minus my over Iyy multiplied by z. Now this formula you all should be very familiar by now. Okay, and then the other one in here you have plus minus, you have tx r over j plus minus vy over izz qz over t and then we have plus minus Vz over Izz U Y O, oh sorry, yeah, YY over T, right? So once you combine all of them, and now we have our transformation. So if this is our X, and for example, this is our Y, then we are able to determine our element, what is our normal stresses, and what is our shear stresses. Okay. So for today's lecture, what I want to focus on, right? This has to go in stages. It's not a straightforward process. Okay. I'm going to teach you how to identify all these that are marked in yellow. Okay. Okay. Now, so we know the most confusing thing is what? Okay. Moment is equal to force multiplied by perpendicular distance. Okay. The unit is in Newton meter or pound inch, right? That is the known unit. Okay. And then we have torque is equal to force multiplied by radius. The unit is in Newton meter or pound inch. Okay. Right. Now, can someone tell me what is the difference between moment and the torque? Okay. And if you look at the units, it's exactly the same, right? So I've seen some lectures at McMaster saying that moment and torque are the same thing, and that is wrong. Okay, that's fundamentally flawed. Okay, moment and torque are not the same thing at all, fundamentally. Okay, fundamentally, they are very, very different. And I'm going to show you what is the difference. Okay, so now I think that's enough theory. Let's look into example number 1. Okay, so I let me see, did I post all these diagrams for you guys? I can't remember now. I was so busy today. Hold on, let me check. No. Okay, I'm going to post these diagrams so that you can use them. You can see them better. Okay, so now I do apologize. I should have done it earlier. Now you can have those. So you click here, you can have all the diagrams. Okay, the diagrams are all there. Right. So we're going to do this one. Okay. So example number 1. Right. So you can see from here. You can roughly see from here. You can identify. Okay, so first thing we do is you identify the location of the element. So for a question like this, it happened to be there. Okay, you can see element H and element K. I'm lecturing now. Okay, in real life you don't see the elements there. Okay, you have to decide. Okay, later on based on your experience, you have to decide where the location of the elements should be. Okay, for now we just say that that is what we're interested in. Then the second, so we identify the location of the elements. So these are the elements. Okay. So the next thing that what we'll do, like what we had before, we are going to generate the geometric axis. Okay, so the next thing, so this is number one. Number two, we're going to sketch the geometric axis relative to the elements of interest. Now, this step is very important. You skip this step, later on you might be in trouble. Okay, and I'll show you what trouble you might get into later on. Because with this Excel centroid, is a way to identify whether it's a very important geometry to identify, is it a torque or is it a moment. Okay, so this is our so this is our geometric axis relative to the elements. Okay, so the next thing that we are going to do, okay, the third step is to identify identify the transformation. Okay, so for this case, the question gives us which is X, Y, and Z. So we know that this is our X, this is our Y, and this is our Z. If it's not given, you have to identify them. Okay, for this case, we are given in the question. Okay, and then the next thing that we're going to do is we are going to determine, or we are going to sketch the structure together with the corresponding loads in the YZ plane, in the XY plane, and in the XZ plane. Sometimes you don't need to sketch all the three planes. Maybe two is enough. Sometimes you do need to sketch all three. Okay. So now we are going to sketch. Okay. So I'm going to copy this so I don't need to go up and down too often. Okay. So what we are going to do is we are going to do the XY plane. Okay. We're going to, so you draw your, so this is your X. And this is your Y. So now we are not going to sketch the isometric view. We're just going to sketch the 2D view. Okay, 2D view. So just a rough sketch. Okay, it does not need to be perfect. So we know that you have something like that. Then you have the structure going upwards. Okay. So it's just a sketch. Okay. 8, 2, 4, 6. Right, from this view. Then after that, you put in your forces. Okay, you sketch your forces. So I have a force over here going at 150 pounds. I have a force coming in this direction at 200 pounds. I have a load over here pushing at 50 pounds. And then I have another